Welcome to today's GibbsCAM Tech Tip. In this video, I will be going over how we can generate some basic 3D toolpath while utilizing only a contour process and wireframe geometry. This is extremely useful when needing to add a top or bottom radius to an edge, and it is also beneficial when working with tapered walls and large or deep chamfers. Of course, there are certain tools available for these types of features, but in a shop setting, these tools may not always be readily available. Utilizing the wall choices aspect of a contour process can get the job done with more common tools we may already have on hand. With that being said, let's get started. When I turn off my rendering, you can see I have a solid model here. This is only for reference and for geometry extraction. A solid is not needed to generate this toolpath. We will be working with geometry only. If you don't have a solid to extract any geometry from, you'll need to draw it out yourself and ensure that it is located properly. Once that is done, we can begin building our process. For this example, I'm going to add this 1/4 inch radius to the top of our part using a ball end mill. When working with the top radius, we need to use the outermost shape of our feature, which would be this bottom edge here. I'll take my 3/8 ball end mill, and I'll load a contour process. I'll update my process parameters and enter my depth values. The way I get my finished Z depth is by subtracting the surface, or the radius, from my surface. And in this case would be 1/4 inch. Next, I will subtract the radius of my cutting tool from that value, which is 3/16. And this will allow the edge of that ball nose end mill to come down and completely clear the radius as it follows this feature and gets to this depth. And then after that, I'll take it just a little extra to ensure that our tool does travel past the bottom of this feature and doesn't leave a lip around this island. Once I have my depth dialed in, I'm going to click on this button here. This will open up our wall choices dialog. You can see here we have a couple of strategies. I'm going to go ahead and choose taper with fillets. This allows us to mill a top or bottom radius, an angled wall, or a combination of any of these three features. For now, we're just looking at top fillet. So I'm going to zero these other ones out. I want to add a 1/4 inch to my top fillet. Below that, there are even more options to help control this toolpath. We can choose to cut from the top down or the bottom up. And we can select between user D-step and shape step. A good rule of thumb is to use D-step when roughing and shape step when finishing. I will show an example of this in just a moment. But for now, let's choose D-step and enter a value of 25,000. This number can be more or less. It all depends on what type of surface finish you are looking for. A larger step is not going to output as much code, but of course the surface finish won't be as nice as a tighter step over amount. Also remember that a bigger tool radius will allow for a larger step over amount while still being able to achieve a nice surface finish versus a smaller radius tool. Next, I will select my geometry. Remember, we need to select the outermost shape of this feature, so that's the geometry I will use. After making sure my machining markers are correct, and I'm cutting the outside of the shape in a clockwise direction, I'll go ahead and hit Do It. And you can see we get some pretty nice toolpath. It makes one pass, steps down and out, makes another pass, continues that pattern as it follows the shape of that 1/4 inch radius. Now, notice what happens if I select the wrong piece of geometry and redo this operation. It disappears, or rather, moves in a 1/4 inch and begins to gouge our part. So that's a good example of why it's always important to make sure we're using the correct piece of geometry. Now, to speak more on the difference between user D-step and shape step, I'm going to look at the front of my part and zoom in on this radius and toolpath. And I'm going to click the shape step button in my wall choices dialog. Once I select shape step, another box opens up for ridge height. This allows us to enter a desired ridge height we are trying to achieve. I'll hit the redo, and you'll see our toolpath change. If I use my hotkeys to flash back and forth between undo and redo, you can see the difference. It now has more passes. This is because D-step is considered a constant step, whereas shape step allows Gibbs to vary the step amount throughout the feature in order to achieve our desired ridge height. To show a little more capability with this feature, I'm going to take my final Z depth to the floor of this part, which I know is negative 0.7. Then I'm going to add a 20-degree side angle and a 3/8 bottom fillet and hit redo. You can see that this toolpath is blended smoothly between these three features. But I'll go ahead and put this back to where I was for that radius, hit redo, and then run the rendering. And you can see we get a nice, smooth 1/4 inch radius on the top of our part without having to perhaps dial in a round over, which can be tricky at times. If you'd like to know more about the Wall Choices feature or any other aspect of GibbsCAM, please feel free to reach out to your local reseller for more information. Thank you for watching and have a great day.